Now we're going to discuss about the angle of declination. All right. So imagine that you are at here. For example, let me draw a diagram. For example, you at the person, and it seems like very giant. Like it's. Let me draw a little bit. Yes. So you are going. Okay, and you are. Your destination is to go to the North Pole. Okay, for example, this is North Pole, and you want to go here. Okay, here, that is the North Pole. Okay, or in other words, you can say that geographic North Pole. You want to go there, you want to reach there. Okay, so you have one compass with you. Okay, you have only one compass, and this compass is showing that the direction. For example, let me draw a compass over here, and if I draw a compass here, let's say for example, if I draw a compass here, I think you can see that, right? So this compass needle is showing that this is the North Pole. This is the direction of the North Pole. Now, if you follow this compass, do you think that you're going to reach at the geographic North Pole? Let's pause the screen and tell me the answer. If your answer is yes, then you are absolutely wrong, because you cannot reach to the geographic North Pole when you follow some compass, right? And where you will reach, if you just strictly follow this compass, then you will reach some point near the actual North Pole, and you'll be able to see that you reach here. Okay, and this is not the North Pole, or this is not the geographic North Pole. This is far from the geographic North Pole, whatever you consider. Okay, so now if you just draw one line, one axis, passing through that particular point, and if you draw another axis which is passing through the actual geographic axis of the earth. Okay, for example, I have drawn this one, and black is not that vibrant in the black, so let's take a different color. Okay, so for example, erase this one, and let's take a different color slightly. White is good. Okay, so this is actual geographic North Pole. Okay, and this one is the point where you have reached. If you can measure the angle between these two, then you'll be able to see that this angle, let's just decrease the width of this pen, and if you will be able to see that this angle is basically some 11.39 degrees. Okay, so the point where you have reached, the axis passing through that particular point, and this actual geographic North Pole, they have an angle difference of 11.39 degree. Or in other words, if I draw this diagram, for example, let's take one circle. This is the two-dimensional representation of the earth, if that is the two-dimensional representation of the earth, and if I take like one arrow from here, and if I just draw one arrow from here, and let's change the color quickly. Let's take this one is orange, and now draw another axis which is passing through here, but this time we'll take some different color. For example, let's take this one. So now you can see that if this is the earth, and this earth is basically the two-dimensional representation of the earth, right? This is a sphere, basically two-dimensional representation. Now there are two axes that actually exist. One axis is called the geographic axis, and another is called the magnetic axis. Now the geographic axis has one pole, and we can call them North Pole or geographic North Pole. We can say that geographic North Pole, right? Similarly, this one is also called the geographic South Pole. Okay, now these two other axes, you can see that this one is called the magnetic North Pole, and this one is magnetic South Pole, right? So now the angle between these two, the geographic North Pole and the magnetic North Pole, is said to be something approximately 11.39 degree. Okay, so this angle will also be 11.39 degrees, as you can see, right? So at the end of the day, if you want to reach at the geographic North Pole, you'll be able to reach over here, and which is not actually the geographic North Pole but the magnetic North Pole, right? So what is the exact way how can we reach the geographic North Pole, right? So if this three-dimensional angle, we can convert this three-dimensional angle in two dimension, then we'll be able to reach at the exact point of the geographic North Pole where we wish to land, right? So now how can we do that? Okay, so in order to do that, we need to understand the angle of declination. This angle of declination. Now what is this angle of declination? I'll give you two idea. One idea, I'll give you the perspective of the earth, and another idea, I'll give you the exact practical purpose, practical idea of the magnetic this angle of declination. All right, so let's say for example you are here. Okay, so as these this compass will direct towards this particular point where this magnetic North Pole actually resides, what you need to do, you need to shift a little bit in the left hand side. So at every point, for example, if I draw a line from here, you can see that this line, this this line, you will reach there. But at this particular point, if you want to reach over here, so these two line are making some angle here, right? So this angle, this angle in the horizontal plane, angle over the earth surface in the horizontal plane, the angle between the geographic axis and the magnetic axis is called the angle of declination. Okay, so this one is called the angle of declination, DCLI, sorry, it's declination, angle of declination. This is the angle of declination. Now this angle we are talking about, now as you can see at various different places. For example, if I stand over here, okay, if I stand over here, I can see that this line clearly coming here and this line clearly coming here. So now the angle here, the angle of declination is this. So these all the places, for various different places, the angle of declination is different. So as you move further from the North Pole, the angle of declination tend to become very low. For example, you are at the point here. Okay, for example, you are here. Let's take black. Now as you can see, this angle and this angle, this is the angle of declination. As you move close to the North Pole, the angle of declination started increasing, and as you move very close to this North Pole, the angle of declination started increasing very rapidly. All right, so as you can see, right, so the compass will show you need to go in this direction, but you need to go in this direction. That means at every different point the angle of declination is different. Now what are the actual case where the angle of declination actually come into play? Okay, so let me show you the basic idea of angle of declination. For example, we are talking about the geographical axis and the magnetic axis. Okay, let me quickly erase this numbers quickly, and let's cut the earth, or cut the sphere or the earth in two different part. Okay, so for example, we are cutting the earth in the two different segment. One is along the magnetic, one is along the magnetic axis. As you can imagine that this one is a half sphere and this part is another half sphere, right? And we have just cut down this earth along the magnetic axis. Okay, so if we cut the magnetic axis along this particular point, now we cut the earth with the geographic axis. If we cut this earth with the geographic axis, then we'll be able to see that here we are cutting. So now these two two half sphere, these two half sphere, as you can see, they're interacting at two different point. Here is one point, as you can see, and here is another point, right? So these two different point at where this magnetic plane and the geographic plane, they are intersecting with each other. Now if you come closer, right, if you come closer, close to this particular point, here, come here, then you will be able to see that there is an angle that is lying between the geographic plane and the magnetic plane. This is the angle. You can see that this is the angle, and also this is the angle. So this angle for this particular place, right, over the earth, is called the angle of declination for point A. Angle of declination for point A, and this angle is also the angle of declination for point B. So as you can see that, so let's say for example I have one sphere. I have one sphere. Now I want to find the angle of declination at this place. So how can you do that? So what you need to do, just bisect from here along the geographic plane, and now again bisect this point. You should bisect, go through this point. You should go through this point, and this time one through the geographic axis and one through the magnetic axis. For example, here one, you have bisected once. Now again you are bisecting here. Okay, so as you can see, this point is making some angle with the horizontal, sorry, magnetic plane and also geographic plane. So you can choose any plane, because this diagram is getting like fat lines, so that's why I cannot see the angle between the geographic plane and the magnetic plane. But if you can if you can do it very precisely, then you will be able to see that there must be some tiny angle when we are going far from this north pole or the south pole. There must be some angle that exist between the magnetic magnetic plane and the geographic plane, and this plane angle is making, these two planes are making some angle with each other, and we call them that angle of declination. Or in other words, you can see that this blue shaded region is the over the surface of this sphere, right, over the surface of this sphere. So this angle is the plane angle, right. These two planes are lying in some different plane, and the angle is lying over the surface of the earth, right. So as you can see, this angle basically, these angles whatever we have drawn here, these angles are basically the angle between the geographic plane and the angle between the magnetic plane, basically. All right, so this is the angle of declination for this particular place. So if you want to go to the north pole, that geographic north pole we are talking about, then if the magnet is deflecting in this particular direction, you need to know this angle of declination and then add that angle with the deflection, and then you should move your ship into that particular direction to reach the north pole, right. Are you getting my point? So if you are reaching at this particular point, then again you need to see that the magnet will definitely deflect in this particular direction. As you can see, the magnet will deflect in this direction, but you need to move your ship in this direction, because the actual direction is this. So you need to move again this particular angle. So at different point, the angle of declination is different, but you need to always be careful that at every different point this angle of declination is changing, and for every different point there is definitely a unique angle of declination. And this is very crucial and this is very important, because the angle of declination is the thing what we need to get the real direction in terms of using a compass. That's all for angle of declination.